Hello, David Kenworthy here again, and today this presentation is aimed at the members of the Tiverton and Devon Astronomy Society. I spoke to one of their members the other day, and she was extremely helpful, extremely patient, and I apologise if I went on too long. But the reason I called was from this fantastic website that they've produced that covers the area of interest for myself at Stonehenge, which is the Aubrey Circle, and this is the Aubrey Circle that Professor Thom analysed, with a circumference of 330 megalithic yards, which is 897.6 feet. And this measurement can be analysed in very many different ways, and it does work as an eclipse prediction device if you get the right periods in place, and that's what I'm going to show you now. So I've got to go back up here. And there we are. Tiverton and Devon Astronomy Society presentation after a recent discussion with a member. Eclipse calculation at the Aubrey Circle. This is what I was talking about, but I was obviously piling too much information onto the poor recipient. So let's go through it quite slowly. I didn't know anything about history or astronomy. I'm interested in astronomy now. I don't get much chance to go out and look at things, but when I'm in Portugal, it's such a beautiful night sky there, and in the countryside there's very little light pollution, so it's a great place to look at the stars. And the place we go to is near the Serra da Estrela, which is the Mountain of Stars, and it's very appropriately named. So, that said, where do we find out? Where did I go to find out about eclipses? And I went onto the NASA website, and there's this guy called Fred Espenek, who's Mr. Eclipse. He knows everything about eclipses. He knows more about eclipses than anybody that's ever lived, apart from possibly some of the megalithic people. So, what do we need to predict eclipses? What do we need to know? We need to know what I've called the extended saros, which is 6,600 days, and then we need to know the saros, which is 6585 days, 8 hours, and take that from that, we get the eclipse unit of 14.666 recurring imperial feet, representing 14.666 recurring days. Now, at the Aubrey Circle, Alexander Thom, whose work I've been studying for the last few years and writing books about, he suggests that they use 22/7 at the Aubrey Circle, the designers. And you get this strange association using 22/7 with the eclipse unit. You divide it by 22/7, which is there, and you get a diameter of a circle of 4.666. You take that from that and you get 10. And what Thom suggested these people were doing was putting the number 10 into their circles. And the way they were doing it was they were using pi to put 10 into the circle. So we can see how the number 10 is involved in this calculation. And when I first saw this, when I was looking at Fred Espenek's site, and I found this strange number because this is exact, this on the website, the NASA website. It's 6585 days and 8 hours, and he says that. And I thought, well, that's a very accurate and very convenient number to have been produced by almost astronomical accident. And then when I found this, I thought, well, what's going on, because this is a naturally occurring event. And yet we find, if we use 22/7, we find this happening. So I wonder if they thought, when they found this out, if they thought, flipping out, this is a message from the big cheese or something similar. And that's one of the reasons why they preferred to use 22/7, even though, that, as the previous presentation alludes to, they did know where pi was, even if they didn't know what it was, because nobody can know what it is. So where do we find this eclipse unit? And it's actually found in the English mile, would you believe, using Babylonian math. And I apologise for using the word math, but I've just got used to it. And that's that. It's not English, I know. So 5280 divided by 360 is 14.66. That's Babylonian. And that's modern, the modern English mile. But we know historically that goes back to at least the Battle of Hastings. And before that, it was brought over from France. So it's a very ancient unit, and we know that. And it obviously went straight back to the people that designed the Aubrey Circle, which is 6,000 years ago. And again, we know that it was something similar to it was being used 6,000 years ago, but in the Sumerians were using a unit that reconciles to 5,280. So it's not so wild, this suggestion. And also, we know now from DNA analysis that the people that populated the UK, who moved through Europe and gradually moved northwards, were Sumerian and Babylonian people who were extremely competent farmers and brought with them a huge skill set. And they completely repopulated the UK. And we've only just recently found this out in the last 3 or 4 years using DNA analysis. So these ideas aren't so wild as they were when they were suggested by Thom. Because nobody knew, our archaeologists didn't know that we'd been repopulated by Babylonians and Sumerians. So we go to Thom's Stonehenge, the Aubrey Circle, 330 megalithic yards, 897.6 feet. I'm going to multiply it by 100 because they didn't use decimal points. All the maths is fractional. So when you see 3.3 and 2.72, it'd be 330 over 100. Or 272 over 100. And 3.3 is the ancient meter. That's a Babylonian unit of measure, and it's also a Sumerian unit of measure. The Sumerian cubit is 19.8 inches, which is half of 3.3 feet. So we get this 8.976 multiplying those two out. So we find that this is complex, this number, because it's got an imperial unit in it, and it's got Thom's megalithic yard in it. And we're multiplying it out by 100 to get 89760. And this is what we're calculating eclipses against. So we need to know, to predict eclipses, the nodal cycle, 6,800 days, the eclipse danger periods. Thom goes overboard telling us about this in his book. He does it in his first book, and he does it in his second book. He has a novice being trained by a leader, explaining to him how they work out this figure, 173.33 days. It's so important. And then we need to know the saros cycle, the extended saros cycle, which is 6,600 days, which we've already gone through. And we need to be dividing that by the number of full moons, because eclipses occur when there's a full moon. And then we can look at the maths of the Aubrey Circle. 89760 is 6,800 times 1.32. Right, I've done that wrong. It should be 13.2 and 13.6. And then you get 89760. I did this quite quickly, so I made mistakes. Like that. We like mistakes because we can correct them. Right. So 13.2 is a Sumerian unit of measure. It's also an Indus Valley unit of measure. 13.2 inches is an Indus Valley foot. Now, 10 times 11 times 12 is 1320, and that's a quarter of a mile in feet. So we can see how these things are all tying together. So we can also look at the versions of pi that are working in the Aubrey circle. And the first one is Thom pi, and it's 5440, which is 6,800 times 0.8. It's 8/10 of 6,800. And we divide that by this eclipse danger period times 10. And we get what is known as, I've called Thom pi. And it's 3.1384615. Thom mentions this as 3.139 on page 47 of his first book. And I've called that Thom pi. So the other unit of pi, the approximation, is 176 over 560, which is 3.1428571. And at the Giza pyramid, the height is 280 cubits as a radius against a base of 1760. But these two versions of pi are working at Stonehenge. So we can see that the Aubrey circle's counting 6,800 and 6,600. And there's not really any doubt about that. So if we go back now to the Tiverton website, we can have a look at what they say. And what I'm interested is, I mean, it's brilliant, this site, and it's why I tried to get in touch with a member. The first person associating astronomy with Stonehenge was the Reverend Edward Duke. He described it as a planetarium full of significant astronomical alignments, though he named none. Well, we can forgive him for that, but he got the idea. Unfortunately, most of his ideas on the subject were rather fanciful and over-imaginative and not very scientific. And really, we're talking pure science here, predicting eclipses. So Sir Norman Lockyer was the next one. He's very famous. He made errors and incorrect assumptions, which made archaeologists suspicious. I don't see why archaeologists should be suspicious of the work of astronomers, because astronomers are trained in astronomy, not archaeology. So, it doesn't seem to make sense to me, that. So we go then to Gerald Hawkins. Now we're really starting to move now, because he's talking about major solar and lunar events being recorded, extremely unlikely to have been a coincidence. He discovered that lunar eclipses could be predicted through a system of moving stones around the circle of Aubrey holes. So there, we're getting closer now, aren't we? But he didn't quite get it. He didn't quite go as far as the next person did, and that person is this man, Sir Fred Hoyle. He was our royal astronomer, and this is his book on Stonehenge. And in here, he explains how the Aubrey circle can be used as an eclipse prediction device, moving a series of markers around the circle with 56 holes. And he proved that you can predict eclipses doing that. And that's why I thought, well, if he's doing that, what happens to Thom's numbers? Do they predict eclipses? And of course they do. We've seen that they do. So we move down to Stonehenge 1. And this is the Aubrey circle, and we can see that the astronomical alignments are going through the post holes. Summer solstice, sunset, most northerly moon set, most southerly moon. These are so important, and it's what Thom talks about in his books. So, of course, they were predicting eclipses. That's exactly what Thom tells us they were doing. And you don't want to know. You see, this is what Hawkins was saying was they could predict the year of an eclipse. Well, that's no good to anybody, is it? You can't have a knees up on a specific day because you know there's going to be an eclipse in the year, but you don't know when it's going to happen. But what Hoyle did, and what they tell us on this website, which is great, this is the last paragraph. It says, even after Hoyle's more rational efforts, many archaeologists remain unconvinced. Well, I'm not surprised because they don't really know anything about astronomy, do they? Today, it is regarded as remarkable that Hawkins' eclipse prediction method was seen as such an impressive step towards understanding parts of Stonehenge. It is believed that his use of the Harvard, Smithsonian, IBM computer made his theory infallible at the time. We're a bit more knowledgeable about computers these days. After all, it is highly unlikely that even the people of Stonehenge would have been satisfied knowing only the year in which an eclipse would occur. That's a great line. I really love that. And that's why I wanted to get in touch with the people that wrote this. And really, this presentation is for anybody that is interested in the astronomy of Stonehenge. And the person to go to, if you want to know how the astronomy of Stonehenge works, is Alexander Thom. Go to his books. He's written 3 of them. And I promise you that no matter how intelligent you are and how well trained you are, you will find it extremely difficult to go through the process of understanding Thom's methods and understanding the way that he works out how these people were predicting eclipses. And I'm not surprised that nobody has stuck at it, because I'm telling you, it's really, really difficult to go through Thom's work and pull it all together and understand where he's coming from. And it's taken me years and years of research to manage to get to this stage. But now I'm ready to share this work, and hopefully people can evaluate what I'm saying about this eclipse unit, where it came from, how it works, and understand that the people that were putting these sites together came from the Middle East and were already highly trained farmers, builders, surveyors, astronomers, mathematicians. And if we go back and look at this presentation, it's leading on from my previous presentation, which is Complex Ancient Mathematics within Thom's Stonehenge Aubrey Circle Analysis of 897.6 imperial feet, reconciled to Plimpton 322, the Babylonian clay tablet. Pi cubed at Stonehenge using 3 versions of ancient pi approximate: Giza pi, Thom pi, Babylonian pi. Pi squared is 8976 over 91, 897.6 over 91, and pi cubed is 89760 over 2912. 2912 is 56 times 52. And 56 times 52 times 22 over 7 is 91520, and 91520 is 17.333 miles, which is the distance between Stonehenge and Avebury. So that's it for now. That's a lot of stuff that I've thrown at you. But I hope you can understand where I'm coming from. This stuff here is not really relevant. I need to delete that. So that's it for now. Thank you for watching. Sorry if I've rambled a bit, but I think you can see that underneath all this, there's some very, very secure mathematics and astronomy going on. And it's exactly what Thom's telling us, but it's not what Thom understood. He didn't go as far with his own analysis of his findings. He's only done the groundwork, but he's not got the tools that we've got today to analyse his findings. He's not got spreadsheets. He's not got auditing tools. He can't break down numbers, and he didn't have the time either. I've been doing this for years and years because I'm retired. But he's done the groundwork, and I'm just using what he's produced. So thanks for that, and hopefully I'll be able to give you another presentation fairly soon.